Well, good morning, good evening, good afternoon, wherever you might be. Here is our calculus problem of the day. So here we have, we're going to be talking about uh, average value over an interval for a function. So we have the temperature of some city is modeled by this function f of t. You see it's a cubic function, so it's a little bit long, got some decimals, but just a basic cubic function where T is the number of hours after 9 a.m. We want to find the average temperature, average value of this function, average temperature from 9 a.m. to 9 p.m. So we could consider T to be on this interval 0 to 12. And so we want to find the average value on that interval. So the average value of a function is given by this formula 1 over b minus a. So we have the interval a to b, if you will. And we're going to integrate from a to b. We're going to integrate f of t over dt. So very basic integral here. If you remember the formula, it's not anything too difficult. So obviously our interval b minus a would be 1/12. So we'll just write 1/12 here. And we're going to integrate from 0 to 12. Our function, so 57 minus 2.4t plus 0.43t squared minus 0.014t cubed dt. And so this is just basically using the power rule for the antiderivative four times and then plugging in our values. So we'll have 1/12. If you need a calculator, you can use one, but you do want to be careful. So we'll talk about that as we go. But the antiderivative of 57 will be 57t. Now use the power rule. So we have t to the first. We're going to add 1 to the exponent and then divide by the new exponent. So this would be 2.4 over 2t squared. Add 1 to the exponent. So we'll get 3 and then divide the coefficient by 3. So 0.43 divided by 3t cubed, and then add 1 to the exponent again. So we have 4 and then divide by 4. So 0.014 divided by 4, t to the fourth. And then we're going to evaluate that from 0 to 12. Now, you can, of course, divide 2.4 divided by 2 and then get 1.2. You can divide 0.43 by 3, but that gives a repeating decimal that doesn't end. And so you got to be careful with rounding. So I would kind of recommend just leaving these the way they are and putting these in the calculator because you don't want to have a rounding issue. And a lot of students get rounding errors because they'll put 0.43 in the calculator and you get 0.143 repeating. And possibly, I don't know if it would happen in this one, but possibly if you just put 0.143 and then you plug in 12 and then you do the rest, you could have a rounding error. So I typically will try to not do any rounding while I'm in the middle of a calculation like this. So at this point, let's just plug in 12 and 0. So we have 57 times 12 minus, now this one you can, so this 2.4 divided by 2 is just 1.2. No rounding it there. So we'll plug in the 12 there. Now this one we're going to leave like this. And so we have that times 12 cubed and then minus 0.014 divided by 4. Again, this was a repeating decimal, so it's either don't round it at all or keep at least 6 or 7 digits. That's another option too, but I feel it's easier just to not round at all if you can. And then we'll do the minus 0. So obviously when you plug in 0 to all these, you just get 0. So that's a non-factor, but that's always, you got to remember if that's not 0, then you need to plug that in. And so we'll just do this step by step. So 57 times 12, 684. Minus 1.2 times 12 squared, we get 172.8. 0.43 times 12 to the third divided by 3 is 247. 247.68. And then 0.014 times 12 to the fourth divided by 4, 72.8. 0.576, and we'll cut off the zero there. And so now put all that in, we get 1/12 times 686.304, and then put that in the calculator, and we get our final answer of 57.192. And then you can round that off wherever you need to. Um, Now, this of course is a problem where you can think about, is your correct answer, or is your answer a plausible answer? Now, we don't know what city this is. We don't know what time of year it is. So, I mean, I guess the average temperature, and this is in Fahrenheit, could be feasibly anywhere between 0 and 100 degrees, really, depending on where you are and what time of year it is. Um, or less or more, but not too much far out of that range, I wouldn't say. So obviously if you forget to multiply by the 1/12 and you get 686 as your final answer, that's going to be incorrect if we're on planet Earth, you know. Um, so 57 is obviously a very reasonable answer for almost anywhere. Um, and so, you know, remember this formula, know your basic antiderivatives, and this problem is not too bad. So if you have any comments or questions, you can feel free to leave those, or you have any other problems you want me to do, you can drop those in the comments as well.